Hello guys, welcome to my class number 6 on your topic of integration, and I will cover a subtopic of integration of logarithmic function. I'm engineer Goodluck, and you can contact me with my email goodluck.wk@gmail.com, and I'm from Tanzania. Okay, in class number 5 we mentioned this type of integration, integration of logarithmic function. In order to solve this type of integration, we must use integration by part method. Okay, let's recall integration by part general formula. Integral of u dv dx dot dx is equal to u times v minus integral of v du dx dot dx. This is the general formula of integration by part. To understand this scenario, let's consider an example. Okay, example. Number 1, integrate ln of x dx. In this example, ln of x is u or dv dx. We don't understand that u is ln of x or dv dx ln of x. Okay, let's continue. Solution. From the general formula of integration by part, u dv dx dot dx is equal to this one. Ln of x dx is in such that in this you have two functions. One is u and the second one is dv dx. So in this function we have only ln of one of x. We add one, a constant, because it has no effect, and thus we have two functions, a constant one and a second one is ln of x. This is the polynomial and this is the logarithms. Okay, this constant one and this is the logarithmic, which in the order of letting u, first we start with the inverse of trig. There is no inverse of trig in this function, in this integration. Second, we look for logarithms. There is a natural logarithm ln of x, thus we let ln of x is equal to u, and the remaining one will be dv dx is equal to, then since we let u is equal to ln of x is equal to ln of x, then when I differentiate the u with respect to the x, du dx, I get 1 over x. Then dv dx is equal to 1. So when I multiply by dx in this side and in this side, this d of x and this one cancel, remaining is dv is equal to dx. When I introduce the integral sign in this side and in this side, in this side this derivative, this integral cancels this derivative, will remain with v is equal to, and then this integral cancels this derivative, will remain with x plus constant. So I have u is equal to ln of x, which is this one. V is equal to, u is equal to ln of x and its derivative du dx is equal to 1 over x, and v is equal to x plus c. So u is this one, v is this one, and du dx is 1. Then we substitute back. Then we have this integral of the integration of 1 dot ln of x dx is equal to where u is ln of x and where v is x minus integral v is x du dx is 1 over x dot dx. But x dot 1 over x cancel remaining 1, so we have x ln of x minus x plus constant. When we get out x, we have bracket ln of x minus 1 plus constant. Okay. If we integrate log of x dx, this is the same as example 1, except in this case we have log of x. By using algebra technique, we have log of x is equal to ln of x divided by ln of 10. Then integral of log of x is equal to integral of ln of x over ln of 10 dx, which is equal to 1 over ln of 10 is constant. We get out of integral, we remain with ln of x dx. So 1 over ln of 10 is this one, brackets. We have c integral of ln of x dx is equal to x bracket ln of x minus 1 bracket plus constant. Thank you for listening.